students, welcome back to geometry. Today we're going to be talking about the base angles theorem. Now this is quite a bit of explanation for a very easy topic, but as you know, I like to show you guys where stuff comes from and not just tell you some theorems. So the first thing that we have to do is we have to remind ourselves what an isosceles triangle is. Now, an isosceles triangle is a triangle in which two of the sides are congruent. So that means that I would have a triangle like this, where I have two congruent sides. So the two sides that are congruent, we would call those legs. And then we would call this third side that is not congruent the base. Now, I'm going to throw in another piece of vocabulary here, and that's these two right here. These two angles here would be called the base angles. So, this leads us into the base angles theorem. And that states that if two sides of a triangle are congruent, then the base angles are congruent. So, basically what it's saying here is that if I have two sides of a triangle are congruent right here, the base angles are going to be directly across from those two sides, and then those two would be congruent. So let me go ahead and label this A, B, C, and the way we would do that is we would say if AB is congruent to AC, then angle B is congruent to angle C. Now, I'd like to give you guys a quick proof of that, because like I said, I don't like just telling you to accept things. So let's go ahead and draw this triangle. Again, we'll label it A, B, C. And we will start off with AB is congruent to AC, and we're going to start off with that being given. Now, the thing that I want to prove is that if AB is congruent to AC, then B must be congruent to C. Angle B must be congruent to angle C. Okay, so at this point, we're going to do a little trick. So I've got angle A right here, and so all angles can be cut in half. So what I'm going to do is I'm going to draw a line that I'm going to assume cuts angle A in half. So let me just draw that a little bit straighter. There we go. Now, I don't know how big angle A is, but all angles can be cut in half, and so I am going to draw the line that does cut it in half. So now I can say, I just created point D right there, and I'm going to say AD bisects angle BAC. Given. Am I allowed to just say that it's given? Yes, it is, because that bisector does exist. So now that I've said that that's the bisector, I can say angle BAD is congruent to angle CAD. These two angles right here are congruent. And that's because of the definition of the bisector. And now I can say that segment AD is congruent to segment AD by the reflexive property. So hopefully you see what I've just done. I've shown that a side is congruent given. I showed that an angle is congruent because of the bisector. And then I showed that another side is congruent because of the reflexive property. So what I can say now is that triangle BAD is congruent to triangle CAD because of side angle side congruence. Now, what we've done here is shown that I took this triangle, I split it up into two smaller triangles, but now I've shown that the two smaller triangles are congruent, and since those two triangles are congruent, I can say that their corresponding pieces are congruent. So therefore, angle B must be congruent to angle C because the triangles are congruent. So I can say angle B is congruent to angle C because corresponding parts of congruent triangles are congruent. And this is a reason that we use regularly in triangle proofs, so we can abbreviate it. Corresponding parts of congruent triangles are congruent. CPCTC. So that's the proof right there. If two sides of a triangle are congruent, then the base angles are congruent. So, the next thing we want to talk about is the converse of the base angles theorem. Base angles theorem. And just like the other converse that we've done, the converse is backwards. So what that means is that if the base angles of a triangle are congruent, then the legs of the triangle must be congruent. Okay, so this is the same thing that we just talked about, but backwards. So, in this case, again, label this A, B, C. If I start off with angle B is congruent to angle C, then that implies that the two sides are congruent. So I'm just going to write that out. If angle B is congruent to angle C, then side AB must be congruent to side AC. Okay. The base angles theorem has a corollary to it. And corollary is kind of a spin-off. And so what we're going to do here is we're going to have an equilateral triangle. So I'm going to have triangle ABC, but in this case, I'm going to say that all three sides are congruent. So basically what I can say here is that since AB and AC are congruent, I can use the base angles theorem to say that B and C are congruent. However, since I see that AC and BC are congruent, I can also say that these two angles are congruent. So, the corollary to the base angles theorem says if a triangle, let's say if all of the sides of a triangle are congruent, then all of the angles are congruent. Another way of saying that is if a triangle is equilateral, then it is also equiangular. Now, one other thing that I want to point out about this is that if I have a triangle and all of the angles are the same, I should be able to tell you exactly how many degrees they are. So I can say if a triangle is equilateral, if all of the sides are the same, then each angle is 60 degrees. Now remember, all triangles, the interior angles add up to 180 degrees. So if it's equiangular and they're all the same, that means each angle is going to be 60 degrees, because 60 plus 60 plus 60 is 180. The converse of this is also true. So there's the corollary to the base angles theorem converse. If all of the angles in a triangle are congruent, then all of the sides are congruent. Okay, like I said, there's a lot of explanation for a very simple idea. So let me show you how this works. So using isosceles and equilateral triangles, we're going to find the value of x and y in this diagram. So what I would do here is I'm going to look at this and I'm going to say that if I look at this triangle right here with y on it, I see that all three sides are the same. So, I'm sorry, all three angles are the same. So by the base angles corollary, since all of the angles are the same, then all of the sides must be the same. So I can say y equals 4 because of the base angles converse. Okay, and remember, if I'm saying the sides are the same, so the angles must be the same, that's the base angles theorem. If I'm saying the angles are the same, so the sides must be the same, that's the converse. Okay, so since all of these are the same, I can say y is 4, so this is 4 and this is 4. And now I can say, looking at this bigger triangle right here, I've got these two angles that are the same, so that means going across these two sides must be the same. So I can say x plus 1 must equal 4. And again, that's because of the base angles converse. And then I can just solve this really quickly. I can get x equals 3. That's because of algebra. All right, so like I said, it's a bit of explanation for a pretty simple concept. So from here on out, I think you'll have enough information to complete this assignment.